So this right here is row A for this problem 6-4. You are to do 6-4C. So follow this same methodology that I'm about to do for row A. You're going to do it for row C because that's the one that you've been assigned this semester for position, velocity, and acceleration. So this is the velocity. So we start off with finding all instant centers. So I have I12 here, I14, I23, I34. Okay, so those are all the easy ones. Then I look at this right here. And this is where I24 is. Okay? And you're given that omega 2 is plus 10. So this is omega 2 equals plus 10. All right? So that means, right off the bat, that I know that this is moving up like this. So let me zoom up on that. So I24 is moving straight up like that. So what direction is omega 4? Negative or positive? So if I stick my thumb here, and if I'm driving that point up like that, okay, it has to be negative. So omega 4, so right off the bat, I observe that that omega 4 is negative. Okay? Because I know the direction is this, so I take my fingers and point them in this direction, and I pin my thumb through here. It shows that it's negative. Okay? All right. So let's go ahead and find.
Would you get the negative omega 4 use the right hand rule?
Right. Always use your right hand on this.
Wait, does it not work just
So how'd
because
you
it's going
determine
clockwise?
All right, just a second.
How did you determine that it was negative?
Okay, because I looked right here. First of all, do you believe that the velocity of I24, because here's omega 2, it's going like this. So if you think of this link here, if I extended it, so the other thing about these instant centers is it's a point that belongs to each link at the same time. So I could draw this link here kind of like this. Okay? And if I know that omega 2 is going like this, and this point belongs to omega 2, it has to be going straight up. Okay? Do you see that? And then, if I take this link here, this link 4, and kind of draw it so that it comes all the way down here. And so link 4 has this point belonging to it at the same time. So if I know the velocity is going straight up here, what rotational direction does 4 go in? It has to go like that, meaning it's negative. All right?
So what did you have to use the right hand rule for?
I had to use the right hand rule to note that I have my thumb sticking out of the page here means positive.
Can't you just say that counterclockwise is positive?
You can say that too.
Okay. I was just making sure that was the same thing.
Same thing. Same thing. All right, you ready? Okay. So let's find 1, 3. So if I take this right here, draw a line through 1, 2, 3, 4, or 1, 2, 2, 3, and 3, 4, and 1, 4, which is here. This is where I13 is. So I want to look at, okay, if this thing here, here's point A, and I know that this, because omega 2, this is the direction, this is the velocity. The velocity of I23 equals the velocity of A, and it's going up like that. Again, I know that because this is 2, 3, it belongs to 2 and 3 simultaneously, so omega 2 is going like that, so the velocity of A has to go straight up like that. Not straight up, but kind of up like that. So based on that, and remembering that this is a temporary ground, what is the direction of omega 3? Is it negative or positive?
Negative.
Negative. Okay? Because I see that this is like this, so I take my fingers and put them in this direction, and I notice that my thumb is pointing into the page. So I observe that omega 3 is negative. Now, these omegas are what they call free vectors, meaning that they can float anywhere. So I could actually take this here, because here's length 3 here. So you probably be more comfortable having me draw that right here. Okay. All right. So those are just things that we're observing on that. Okay? All right, so let's back up here. And the velocity of A, let's look at the velocity of A. The velocity of A equals the velocity of I23, which equals omega 2 times I12 I23. So this equals, I put 10 in here, so this is plus 10, or does it, actually, I'm not going to put that because you have to look at the magnitude. You look at the absolute value. And then I measure from 1, 2 to 2, 3, and you notice that that is 2 units, 2 centimeters. So this is 2 centimeters. So this equals 20 centimeters per second. That is the magnitude of the velocity of A. And I notice that this angle right here, let me zoom up on it. This angle right here is, in the problem statement, theta 2 equals 30 degrees. Is that even showing up? Theta 2 equals 30 degrees. Okay? That's given in the problem statement. So what I do is I add 90 degrees to that. So I get the velocity of A equals 20 e to the j 30 degrees plus 90 degrees equals 20 e to the j 120 centimeters.
Why do you add 90 to it?
Because you basically have the j operating on this thing here, and if I measure this angle right here, if I measure this angle right here, I know that's going to be 120 degrees because this is 30 degrees. This angle is 30 degrees. Right? So what we're going to do is we're going to box that in. Then, the velocity of I23 equals the velocity of A, which equals omega 3 times I13 I23. So I measure this distance right here. I note that that is equal to 3.3 centimeters. I know that this here is 20. So I have 20 equals omega 3 times 3.3 centimeters. And then I say that omega 3 equals minus 6 radians per second. Let me box that in. So again, I know I23's magnitude is 20. That's why I put that here. I'm trying to find omega 3. I measure this distance, physically measure the distance from here to here. And I also know from observation that omega 3 is in the negative direction, so I put a minus sign in front of it. Okay? Let's look at the velocity of P here. The velocity of P equals omega 3 times I13 to P. So this equals, and let me just use the magnitudes here, 6. And if I measure this distance from here to here, and I measure that, I get 6.8. So that equals 40.8. And because my omega 3 is going negative, that means that this thing here is going like that. That is the velocity of P. And I physically have to, on these problems here, I have to measure the angle. And so when I measure this angle here, I get that this angle right here looks to be about 58 degrees. All right? So therefore, the velocity of P equals 40.8 e to the j 58 degrees. I'll box that.
How do you know the direction of P?
How do I know the direction of the velocity of P? Okay. Point P belongs to length 3 here. All right? The instant ground for 3 is I13. I know, I observed from earlier that I13 makes omega 3 go like that. So what I do is, the velocity of P can either be going like this or like this. Because omega 3 is going like that, it's driving that thing up like that. Okay?
How is point P on 3?
Because it's welded right here. This is one big link. All right? Okay, so that's the velocity of P. Then the velocity of B equals the velocity I34, which equals omega 4. Hold it, let me do this. Omega 3 times I13 I34. Okay? And so with this here, I have, I measure this. This is 6. Again, I'm just using the magnitude. And I measure 1,3 to 3,4. And when I measure that, I get 6. So this equals 36. Okay? And because I know that omega 3 is negative going like this, then I know that the velocity v, that's the velocity of v. Okay?
Is that from P to I3 or I34?
That's from 1,3 to 3,4.
What about how'd you get the angle?
How do I get the angle?
Yeah.
This is
Um,
90 degrees, okay? And if I know what theta 4 is, here's my theta 4 down here. So basically on this here, I take theta 4 and I subtract 90 degrees from it in order to get this angle right here. So this angle right here, when I measure it, I can grab it right off of theta 4 if I want to. But if I measure this angle right here, that angle turns out to be about 28 degrees. Or 27 degrees. Therefore, the velocity of v equals 36 e to the j 27 degrees centimeters per second. All right. And then the one last step that we do here is the velocity of I34 also equals omega 4 times I14 to I34. And when I measure this right here, from 1,4 to 3,4, well, that's simply the length of the fourth link, which is 9. So this is 9. And I know that this here was equal to 36. So that implies that omega 4 equals minus 4 radians per second. Why did I put the minus 4 in front of there? I'm asking, why did I do that? Because we observed earlier that it was negative. Okay?
I-13 is not always going to lie on VO4, is it? If it doesn't, then when you're doing the velocity of point B, you make the right angle from VO4 or from I-13?
From 1,3 you draw up to 3,4. So what you asked, say that again?
Okay, so you know how the velocity is always at a right angle from the ground? Basically, because I know
To that
that in
point.
this